Hello and welcome everyone. This is Benham from Banks and Market. Today I want to talk about a very simple topic called percentile. When I teach topics such as value at risk, in the methods, for example, the method such as historical simulation and Monte Carlo simulation approach, we need to make use of the percentile function. And because of the data size, which tends to be heavy when we compute VR using historical simulation and Monte Carlo simulation, we make use of Microsoft Excel when we compute percentile. So I just wanted to give you some background knowledge related to the percentile function in Excel, and that way also help you understand about the percentile. Because in Excel, there are different variants of computing percentile, it's important that you've got good understanding of those variants. And this is the main motivation of this video. So firstly, you may want to see the definition provided in Wikipedia. And if you read, it says, a percentile is a score below which given percentage of scores in its frequency distribution falls. That is exclusive definition. Now, if you see on the inclusive definition, it says a score at or below, then that becomes inclusive. So the Excel function, which you see Percentile.EXC is exclusive one, and if you see INC is the inclusive one. So we will talk about them in this very short video. So firstly, how you used to compute percentile when you were in your school days. Basically, you used to use this formula. So we are going to use the same formula in this data set. So I've just taken this data set from Wikipedia, and so that you can also follow the explanation given within Wiki. So there are different ways of finding percentile. I've just used the third variant here because that's what I used to do when I was in school days. So this is the third variant, and this is the example exactly that I have taken. So these numbers 15, 20, 35, 40, and 50. So these are the numbers, and the good thing is the numbers are already organized in order. So if it were like 35 here and 20 here, you would organize them like 20 first, then 35. Okay, so in terms of ranking, we can quickly give these 1, 2, 3, 4, 5 here because they are already organized in ascending order. Now we can find the percentile using the formula, and if we see here, it is saying 40th percentile. So that's what I'm going to do. 40th means 40 divided by 100 using the formula times n plus 1, which is n equals 5 plus 1 is 6. So that 6 times 40% is going to give me 24. So that's 2.4 will be the percentile rank. So now I need to find the exact answer. So I now know that this is going, the 2 is 20 in the rank 2, and then plus 0.4 would be in between this 2 and 3, which is 35 minus 20. And there I have got 0.4 means basically 0.4. So therefore I'm going to get the answer, which is 26. So therefore 40th percentile here is 26. Now if I apply the Excel function equal percentile.inc, which takes all the numbers here, then I can highlight like this and say 40%, and I'm going to get the answer. So the answer I'm getting is 29. But now I'm going to make use of the percentile.exc function, then see what answer I will get. And this time I should get 26. And kth percentile is what I need to type in, and I get 26. So this is using percentile.exc, and this was using percentile.inc. Remember, what is the proper traditional definition of percentile. The traditional definition I just said to you to read in wiki here. The first part, which is exclusive definition, is actually the traditional percentile definition. Some time ago, Excel only had the percentile without INC or EXC. And let me also tell you that if you use the simple percentile function without INC or EXC, you are going to get the answer exactly similar to the INC function. So percentile and INC gives you the same answer. It's only EXC which gives you a different answer. So we just want to understand what is happening with this EXC. Firstly, on the definition, what you need to understand is the traditional definition of percentile is basically percentile. I'm just writing here because it's important that my students are not confused. Percentile is the, in a way, you can say interpolated data point below which k percentage of the data lies. Okay, so that's the definition. With this in mind, now what you can I'm going to put it somewhere here. Okay, so that's the definition. What you need to remember is Percentile.EXC in fact uses the algorithm which is going to avoid the k percentage below this and above this. So therefore lower and upper bounds are important. So what I'm going to do next is just try what is the lower and upper bound here. So if I do equal 1 divided by n plus 1 here would be 6 because I've got a total of 5 numbers. So 1 over 6 gives me this. And if I see for the upper bound, so that would be 5 divided by 5 plus 1, 6. That's 83% and 16.67%. Now, you can try this one out, which basically means try the Percentile.EXC function for these upper and lower bound. And what should happen is you will not get the answer if you try it for below 16.7%. So if you try it for 17%, you should get the answer. If you try for 16.8, you should still get the answer. But as soon as this number is below 16.7, let's say 16.5, then you won't get that. If it is below the number which is the lower bound, such as, let me see, 15, you're getting this, but, oh, sorry, I haven't put the function EXC here, okay? Sorry about that. So I was saying if you put 17, it works, but if you put 16, then it doesn't work, okay? Now, similar, this was something we tried for the lower bound, and if we now try for the upper bound, then you will see that it is same, and it doesn't work if this k is higher than 83. So if it is 84, it doesn't work, but as soon as it is like something like 82, it works. As soon as this is something like 17, it works. Okay, so that's basically the difference between INC and EXC. If you follow the correct definition of percentile, the traditional statistics given, which is this, which is also explained here, is a score below which given percentage which scores in its frequency distribution falls, then you should be tempted to make use of the .exc function. Now, with this, you should also understand that if you use EXC function, then you should not be able to get 100 percentile. So, for example, I'm just going to make some randomly generated number like this one. I'm going to take it down. Let's say it's like I've got 300 point of data, and now I'm just trying to find out equal percentile.exc, and then I say all of these and 100%, which is basically means the highest number in that observation, but it doesn't give me. But if I were to do the same, but without, instead of EXC, if I were to do INC, then it would give me the number 2338. And if I find the max here for all this data set, maximum, then this number here and this number here is matching, as you can see. So INC is inclusive of all the values, whereas EXC is not. That's the point I wanted to make. Okay, so thank you very much for your time, and thank you very much for listening this video of mine. See you shortly. Bye bye.